So, welcome participant. This is Zahid Bashir. Today, I am going to discuss some further considerations regarding panel data analysis. And yesterday, we have in the last session we have discussed in detail about the first generation and second generation data analysis technique. We have considered t greater than 25 and n greater than 25 data set. I have shared the data set with both of the participants. For example, this was the data set T and N greater than 25. So this was the data set I have shared with both of my participants. And this data was related to middle income countries. So I have used this data set and I have found some initial considerations regarding this data set. For example, when I have applied a number of basic things with this data set. This is the consideration n greater than 25 and t greater than 25. Number of countries, companies, or individuals are greater than 25, and number of time period are also greater than 25. So the following procedure was applied in the previous session. First of all, we declare the data set to be panel. Then we check the summary correlation, and then we applied first of all fixed effect, random effect, and pooled OLS. If you missed the session, you can watch my previous session video on this. Let's start from this part, because after this, we need to understand the further considerations. So this is the data set, but we need to open our Stata folder. So this is the Stata. We need to open our data set that we have been using previously. So first of all, I need to declare here the data set as a panel. So xt set ID and years. This will declare the data set to be panel. So if you want to see in the data set, you can verify there are approximately 53 countries here, while the data set is also greater than 25 years time period. It is 1980 to 2020 data set. It is almost 42 to 43 years long data set. So it meets our initial condition, which is n greater than 25 and t greater than 25. So we have declared this data set to be panel. Then we need to apply the fixed effect, random effect. So I will apply it xt set, xt rec, sorry, FTI as a DV, FT, CF, SEG, GDP, GR, GDPPC, drop, inflation rate, exchange rate, and real growth rate. Then fixed effect. Then we need to apply the estimate store fix. Then we need to run the random effect command as a procedure, like this, random effect RE. So estimate store random, then Houseman fix random. Now the result of Houseman indicated us that fixed effect is a suitable choice for our model. So what we need to do, as we have finalized that fixed effect is suitable choice, the next step is to check the cross-sectional dependency based on the finalized model. If your fixed effect is final, you need to check cross-sectional dependency. If your the random effect is final, you still need to check the cross-sectional dependency. If your pooled effect is final, you still need to check the cross-sectional dependency. So as a next step, we need to check the cross-sectional dependency. For this, we need to run the model with the with robust command. This is basically required as a step. So as fixed effect is final, using Hosman test, so we need to run the fixed effect command with robust estimate, VCE robust. Now, this is basically used to control the group level panel heteroscedasticity in your results. So this command is basically run for this purpose. So after doing this, what we need to do, we need to run the following command to check the cross-sectional dependency in our data. The command is xtcsd pasran abs. So if this command is unrecognized, you need to install it using ssc install xtcsd. So it is already installed in my system. So I just need to run this command. So it will give me these results from which we need to see the PR result. The PR is basically the probability result, which is less than 5%. So what is the interpretation? If the PR value is less than 5%, it means there is cross-sectional dependence in the panel. But if the PR value greater than 5%, it means there is no cross-sectional dependence. So in our case, it is found that there is cross-sectional dependence in our panel. So what we need to do next? Always remember when you are dealing with t greater than 25 and n greater than 25 condition, you need to finalize the model and you need to check the cross-sectional dependence. If cross-sectional dependence is present in your model, you need to estimate unit root testing using second generation unit roots. But if cross-sectional dependence is not found in your model, you need to estimate unit root using first generation unit root like IPS and Lin 11. So in our case, as the cross-sectional dependence is found, so we need to consider second generation panel unit root testing for next consideration. So let me tell you the further procedure. So what we need to do, we need to apply panel unit root as a next step, whether our model is uh, uh, whether our model provide us cross-sectional dependence or not. So if we found cross-sectional dependence, let's suppose this is the case which is relevant with our model, we need to apply the second generation unit root test. There are two types of tests available in Stata for second generation unit root test. But if cross-sectional dependence is not found, then we need to apply the first generation unit root test, that is LLC and IPS. So in our case, the cross-sectional dependence is found. Therefore, we need to run these two uh, 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 panel unit root tests. So what is CIPS test and how it is run? Always remember, if you are using CIPS for the first time, you need to install it. So what is the procedure? SSC install CIPS. So it will check and it will install. It is giving SSC install CIPS not found at SSC. Search CIPS. So you need to click on this. It is providing two options here. The second option says Pasran panel unit root test in the presence of cross-sectional dependence. That is XTCIPS. Yes, This second option is basically more suitable. You need to click on it and you need to install it. Click here to install. So you simply need to install this command in your system because we are using first time this command xtcips. We need to go to the previous screen and again we need to go to the previous screen and close this option. So xtcips is installed. So what we need to do next? We need to check the panel unit root testing at levels. It means at zero difference. And we need to also check the CIPS at first difference. So what we need to do, this is the basic command that we need to run with friend or without friend. So for doing the panel stationarity, always try to run the command uh, with with friend. That is basically required. So you need to run this command. I am just copying this command from here. All right, like this. So xtcips, then you need to put your variable. Like for example, I am going to check the stationarity of my dependent variable, which is FDI. So I need to put my dependent variable here. Then max lag 2 and BG lag 2. It is the basic requirement of this stationary test. So we need to put max lag 2 and BG lag 2 and trend. So press enter and you will find the results. Just wait for the results. It is working. So these are the results of Pesran panel unit root press with cross-sectional uh, uh, results. So what you need to see here, first of all, you need to see CIPS coefficient value, and you need to compare this value with critical values like these. If your CIPS value is greater than your critical values at different levels, for example, 10%, 5%, and 1%, if your CIPS value is greater than these value, it means your variable is stationary and it is stationary at zero difference or at levels. So this is the interpretation. I have also write here the interpretation. If the absolute coefficient value of CIPS is greater than the absolute critical value at all level, 10%, 5%, and 1%, your variable is stationary. So what we need to do, we need to create a table here. For example, let me create a table for your consideration. Go to panel, second generation test. For example, I am going to report my table here. Panel unit to output table. This data does not provide an output view of your table, so you need to create it manually. You need to put here, you need to put here your table. In the first column, you need to write here the variables. Then you need to write here at levels. Then you need to write here at first difference. All right. So always check the stationarity using trend version that I have used here. I will let you show how to write your output here. So the first variable that I have used for checking the stationary was FDI. And I am going to place here my results for for CIPS test, you need to include another layer of row here. For example, insert above. So we need to put here another row. So layout eraser, yes, this one. Because I am using CIPS as a second generation unit root testing. So I need to place its name here like this. So what I need to put it here, I need to write here the CIPS value, which is minus 0.084. I need to copy this value here like this. And I need to place here 3 star, which means it is stationary or it is significant at 1% level. Because if you see the results, this value, this value of CIPS is greater than the critical value of 10%. It is also greater than the critical value at 5%, and it is also greater than the critical value of 1%. So 1% means 3 stars. Sometimes your CIPS value may be greater than the critical value of 10% only, then you need to put only 1 star. In that case, it may not be greater than 5% or 1%. So you need to place these stars like this. So because this value is greater than 10%, 5%, as well as 1%, therefore I need to place 3 stars. The next thing I need to do is I need to check the CIPS at first difference. In case of first difference, what is the changes in the basic formula? Previously, I used this formula. I replace var variable with my variable. Now I am going to put d dot with my var variable to make it first difference. So I again going to use the same formula like this. I need to put it here, and just I need to place d dot before my variable d dot. Do not create any kind of space between FDI and D. You need to put dot before FDI along with D. It will create first difference and it will estimate your stationarity at first difference. So you need to run this command and it will show you the stationarity of your variable at first difference. So you need to see the value minus 6.303, and it is also greater than these 3 levels. So minus 6.303, you need to place this value here at first difference, and you need to place 3 stars because this value is significant at all levels. So after doing this, what you need to do, you need to apply the same procedure with all other variables. Like you need to consider the next part is FD. So copy this formula here, and you need to replace only the next variable, which is FD, like this. And you need to find out its value. Its CPI's value is minus 3.255, and it is also greater than all significance level. So you need to place this value because it is created at levels. So you need to place 3 star because it is significant at all levels. The next thing that you need to do here is you need to create the first difference of the same command. So you just need to copy this formula like this, and you need to place d dot before fd in the same way that we have considered previously. So it will show you the stationarity at first difference. So CIPS value is minus 5.753, and it is greater than all the critical values at all the levels. So it will also be shown with 3 stars here, like this, 3 stars. The next one is the the next variable is CF, which is capital formation. So what I need to do, I need to copy the formula at level. This is the formula which I use for considering the stationarity at level. So I need to replace FD with CF like this. And press enter. And you will find now, if you see the value CIPS is greater than the critical value at 10%. It is also greater than the critical value at 5%, and it is also greater than the critical value at 1%. So we need to put this at levels with 3 stars CF, and I need to create at first difference in the same way. Just copy the formula, put it here, and place d dot before CF. Run the command, and you will find the CIPF value, which is greater than at 10%, 5%, and 1% at first difference. So you need to place this value here with 2 star again. Now, what are they showing? They are showing that your variables are stationary at levels, as well as they are stationary at first difference, because the 3 star indicates its significance. So they are stationary at levels as well as at first difference. Next, I need to see, because there might be chance that when you are testing the stationarity of other variable, they may indicate you some mixed results. So you need to again use the same formula and replace this with your next variable, which is SEG. It is giving you minus 4.679, and it is greater than all level. So I need to place this value here with SEG because it was greater than all levels of significance. I need to check this value at first difference also. So place D dot before SEG like this. This value is also greater than critical values at all levels. So I need to place 3 dot here again. The next variable is GDP growth rate. So I need to check its stationarity in the same way. Always remember that whenever you need to check the stationarity, you need to check the stationarity of all the variables, whether it is dependent variable or independent variable, because we need to see whether it gives us some similar results or different results. So GDP growth rate is also significant at all levels. GDP growth rate, and we need to check its stationarity at first difference also. T dot GDP growth rate. So it will indicate us the stationarity at first difference. You can see here the value is greater than the critical values at all levels. So its first difference is also significant here, highly significant with T star. The next is GDP per capita. So we need to check the stationarity of GDP per capita also from here. I need to copy the same formula. I need to replace this variable with GDP per capita like this. So it will indicate us some value. Now, there are some different results. If you see, the CIPS value is minus 2.520. While if you see, this value is less than at 10%, at 5%, as well as at 1%. So this value is basically this value is less than the critical values at all levels. So we can say this value is not significant. So we assume we can conclude here that GDP per capita is not significant at levels or at or without first difference. So we have find out the first variable which is not significant at any level of CIPS test. So we need to check whether it would be significant at first difference or not. So we need to apply the same formula here with creating first difference T dot before GDPPC. So click enter and you will find the CIPS value which is greater than 10%, 5%, 2.68. It means this variable is significant at all levels using first difference only. So what we have concluded here, we have concluded that GDPPC is significant or stationary at first difference, while it is not stationary at levels. In the same way, you need to decide other variables stationarity. Like for example, we need to check the trade openness here using the same formula. Use first of all at levels formula. You need to replace TROP here like this. Now the value of CIPS is minus 2.402 and it is less than 2.53, it is less than 2.58 and it is less than 2.68. It means this is also not stationary at levels. So we need to place here this value without any star because it is not stationary at level. Now I need to check its stationarity at first difference. So how can we create the first difference? We need to place D dot before TROP and click enter and you will find CIPS value minus 5.63673 and it is greater than critical values at all levels. So the first difference has made this variable stationary at all levels. We need to see the next variable too in the same way, that is inflation rate, because this is a length procedure but always remember you need to conclude your stationarity test based on the findings of all your variables. So there are only three variables remaining, so we should continue this procedure. So let me in, estimate the stationarity of my next variable here. I need to replace TROP with inflation rate, INFR, and I need to estimate its stationarity. If you see, the CIPS value is minus 4.193, and it is greater than the critical values at all levels. So we can say that this variable is stationary at levels. So we need to place the sterics here with INSR, and we need to check the stationarity at first difference also for this variable. And we need to place B dot for this and click enter. And you will see the result. The CIPS value is greater than the critical value at all levels. So we need to place here this value with 3 sterics or 3 stars. Now two variables are remaining, after which we will decide what we need to do next. The next one is exchange rate. So we need to check the stationarity of this variable too. So we need to replace this one with exchange rate here. Click enter. Sample may not contain gaps. All right. I need to check it whether it will work with max lag 1. Sample may not contain gaps. Maybe it will work with without any lag. If it is not working, we should exclude trend from it. It is still giving some issues with this variable. Maybe this variable is not feasible here. We need to check the same command with other variable. I will find out what is the issue with this variable, why it is not running the command, it is giving some error. So let me check the stationarity of my last variable here. So it is giving the result, the similar results. The value is greater than the critical values at all levels. So I need to place 3 sterics, RGR, and I need to check the first difference stationarity for the same variable here by placing B dot before the variable, and you will see the results, the similar results. This value is greater than the critical values at all levels. So you need to place this value here. Now, the next thing that you need to understand is the decision. What we conclude from here. Basically, you need to understand that all of your variables are stationary at levels as well as at first difference. If you see here, that majority of your variables are stationary at levels and at first difference, but there are two variables who are not stationary at first difference, but who are not stationary at levels, but they are stationary at first difference. So what we conclude here, we have concluded here that it indicates mixed stationarity at levels. So what we need to do next? Always remember, you need to follow the guidelines here. We have checked the cross-sectional dependency. We have estimated the unit root using second generation unit root using CIPS. If we found that all of your variable, including your dependent and independent variable, they are stationary at levels, all your variables, dependent and independent, if they are stationary at levels, zero mean level, you are going to use common correlation effect as a estimation method of your hypothesis. But if your dependent variable, they are stationary at first difference and independent variables are stationary at mixed, means some of the variables are stationary at first difference, some of the variables are stationary at levels as well as at first difference, then you are going to use dynamic common correlation effect. So what we have decided here, because this result shows mixed stationarity, so we have concluded here that we need to use dynamic common correlation effect model based on these results. But if all the variables, they show stationarity at levels as well as at difference, or as at first difference, levels mean 0 and first difference means 1. So in that case, we need to use simple common correlation effect. So how can we use it? I need to show you the procedure, but the time for today's session is going to end. So I will show you the basic command. Maybe you would run it and you would find out your results. So this is the command. If DV is stationary at first difference or 0 level and IV are mixed, then we need to use this command. So I will let you know this procedure tomorrow.